Hello, I'm Dr. Olson, and this is a video for Math 100 on Section 2.1. Section 2.1 is on using lines to model data. Let's take a look at the types of questions and the things we're going to be looking at here in Chapter 2. Section 2.1 is using lines to model data. We're going to be looking at real-world situations. Visitors to the Grand Canyon and all kinds of various information. We're going to have a scatter plot of data, and we're going to be having a line of good fit. A model is a mathematical description of an authentic situation. We say the description models the situation. And we're going to be using a line on graph paper. So this is another example of a scatter plot, couple scatter plots. It is going to be important, as usual, to label the axes. This is the A axis in this example. This is the P axis in this example. And the place where the line crosses the A axis is the A intercept. In this case, it's 71,0. And this point is the P intercept. It's where the line crosses the P axis. And this point appears to be about 0,106. So if we get over here to the homework, in the homework in Chapter 2, we're mainly going to be dealing with real-world applications. So number 3 here, percentages of Americans ages 12 or older who have listened to online radio in the past month, and we have some data here. Percentage of tax returns that were filed online. Number of internet users worldwide, all various applications, oftentimes a data set. The first handout I'd like to look at today is the process of creating a model. And this process is going to be used throughout the rest of the course in all the chapters. So there's going to be a real-world scenario, and you need to read this scenario and familiarize yourself with the information that's being given to you. And there's going to be two quantities. There's going to be an input quantity, which is the independent variable, and there's going to be an output quantity, which is the dependent variable. And these quantities are related to one another. We're going to define two variables. We usually use a letter for each, or we could use function notation like f of x or c of x or something like that. And we're going to write down using words what these variables stand for, and I'm going to do an example shortly. After we write the definition of the input variable and the definition of the output variable, then we're going to be getting an equation which shows the relationship between the two variables. So let's take a look at our example down here. In the example, the natural wood manufacturing company produces computer desks. Each month, the fixed cost, that's the overhead cost, is $2,900. The cost to produce each computer desk is $53. We wish to create a model showing total cost as a function of the number of computer desks manufactured. So let's just understand the scenario. We have a manufacturing company here, and they're manufacturing computer desks. You might think about what overhead cost means. These are sometimes called fixed costs. Maybe it's the cost to rent the building, it's the utilities like the electric bill, the gas bill, and so on. And generally, those costs do not change much from month to month because we have to pay the electric bill and we have to pay the rent and so on. If we were to produce one computer desk, the cost to produce it would be $53. And so this might be the wood and the nails and the glue and the paint or finish that is going to be used to manufacture that computer desk. And this is the cost of actually manufacturing the desks will go up the more desks that we produce. We wish to create a model showing total cost as a function of the number of computer desks manufactured. So here's this phrase that we saw on our blue handout as a function of, right down here, the quantity in front is dependent on the quantity back here. This is going to be output and this is going to be input. So I'm going to define my input variable as X. It's one of our favorite letters to use for input. You don't have to use X, but you may. X equals the number of computer desks manufactured. You want to be descriptive. The output is the total cost. I'm using function notation this time. C of X equals the total cost in dollars of producing the computer desks. This is the input quantity. And this is the output quantity. These are our two variables. Now, how are they related? Total cost is equal to 53X plus 2,900. 2,900, that's our fixed cost. It's going to be there all the time. Even if we didn't produce any computer desks, we still have to pay the rent and electricity. And this is going to be 53 times X. X might be 5 computer desks, be 53 times 5. Maybe it's 10, 53 times 10. Maybe it's 100, 53 times 100. And you'll notice here that this is Y equals MX plus B. That's no X. So important thing to realize here is this is what's called a 3-part model. And we're going to be making 3-part models throughout this course. There will be 3-part models on every exam and the final exam in this course. The first part is the definition of the input variable with units. If it's in dollars, indicate that. If it's in inches, indicate that. Whatever the unit is. Definition of the dependent variable, which is the output variable. Once again, with units. And then the equation showing the relationship between the independent and dependent variable. And typically in this course, the dependent variable, the output variable, is on the left-hand side, equal to an expression involving X. And we're going to see examples of this as we go out throughout the course. So this is kind of an introduction to chapter 2. Now, I will say that here in 2.1, we are not going to be having the equation, but right away in section 2.2, we will be getting the equation. Now, if we turn to our 2.1 handout, using lines to model data, we will use the process of creating a model. Now, this did not get photocopied on blue paper this year, so we'll cross out blue. It's this handout right here. And the model is always going to have 3 parts. We're going to be given a table of data. You're going to be making a graph. Okay, so I'd like to take a look at some examples. So we're going to go to section 2.1 in the book. And the first example that we're going to do is number 3. Okay, let's take a look at number 3. The percentages of Americans ages 12 or older who have listened to online radio in the past month are shown in table 10 for various years. So we can see that internet radio was increasing in popularity in this data set from 2008 through 2016. Let P be the percentage of Americans ages 12 or older who have listened to online radio the past month, T years since 2005. Now, we need to understand what T years since 2005 means. For example, T equals 3 represents 2008 because it's 3 years after 2005. T equals 5 will be 2010 because it's 5 years after 2010. This is called resetting the clock. Let me go ahead and show you another example of resetting the clock, then we'll return to number 3. This is on our handout. This is very common in this course. Let's say we have the years in our data set 1970, 1980, 1990, 2000, 2006. And let's say we define T to be the number of years since 1970. The actual T values that we would use in our graph and in our calculator would be 1970 minus 1970, which is 0. 1980 minus 1970 is 10. 1990 minus 1970 is 20. 2000 is 30 years after 1970, and 2006 would be 36 years after. So we have to subtract to get the T value. Now let's return to question 3. And let's define our variables. We are going to be making a scatter plot, so we are going to need to graph this. So you need to take out a piece of graph paper. So over on our graph paper here, T equals years since 2005. And the book is telling us to do it that way. And P is the percent of Americans who have listened to online radio. Percent of Americans who have listened to online radio. Well, in the last month, but maybe I'll shorten it that way. You can shorten it a little bit, but don't shorten it too much. So let's now look at our data set. Our data set for number 3, 2008 will be 3. This will be 5. 2012 will be 7. This is the year here is going to be on the horizontal axis. And on the vertical axis, we're going to have the percent. That's the output. So the first thing we need to do is figure out the scale on the percent. My largest value is 57. So let me show you how to calculate the scale. Scale for P. I'm going to take 57, which is my largest value, and I'm going to divide by 10. Because 10 is basically how many squares I want to have on the graph paper. If I have each square on my graph paper be 1, the graph is going to go all the way off the page. 57 divided by 10 is 5.7. And then I'm going to round to something convenient. A convenient value will be 5. So I'm going to use 5. Now I could use 6, but I can count multiples of 5 easier, 5, 10, 15, 20 than multiples of 6. So when I make my graph, each square is going to be 5. So maybe we'll write that in our notes for emphasis, each square on the graph. Now I need to grab a ruler so we can get ready to make our scatter plot. Okay, so my horizontal axis will be about right here. My vertical axis here. And along this axis, this horizontal axis, I'm just going to have one square be 1 year. So this is the year 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. 2016 is my largest value. 2016 minus 2005 is 11, so I need to go up to about 11. And we said that each square was going to be 5 on the p-axis. So we'll start here at 0, 5, 10, 15, 20, 25, 30, 35. And it looks like I need to go up to 57, 40, 45, 50, 55, 60. And this is the p-axis. Make sure that you label that. And this is the t-axis. Make sure that you label that. So now we're going to get ready to plot our points. All right. The first point is 2008, 21. 2008 is 3 years since 2005, so it's going to be 3, 21. So I'm going to come over here to 3. I'm going to come up to 20, and I'm going to go just a little bit above to 21. That's my first data point. Then we have 2010. That's 5, 27. Over to 5 and up to 27. So here's 25, 26, 27, a little bit above 25. 2012, that's 7, 39. 7, 39, which is just a little bit below 40. As usual, since this is a video, if you need to slow down, you can just pause the video. The fourth data point is 2014, which is 9 for T, 9, 47. Here's 9, 47. Here's 45, a little bit above will be 47. And finally, the last data point, 2016, that's 11, 57. 11, 55, 57. Now, these are not a perfect straight line, but it's pretty close to a straight line. So I'm going to be using my ruler here, and I would like to have a line so that some of the points are slightly below and some of the points are slightly above, and the line's probably going to go through many of the lines. This is a line of good fit. This is our scatter plot. Now let's take a look and see what the questions are. This little graph here is just to give you a hint of one possibility of how to do the graph. Draw a scatter plot. We did part A. Now we're going to be making some predictions. Predict the percentage of Americans ages 12 or over who have listened to online radio in the past month in 2021. Okay, for part C here, for part C, 2021, we need to think about our definition of T. T is number of years since 2005. So I need to subtract 2005 from this, and I get 16. T equals 16. So I need to find the point on the graph where T is 16. So I've got 11, 12, 13, 14, 15, 16. And it looks like I'm going to need to extend my line here a little bit. This is predicting beyond the data. So I'm going to be using for part C here, 16. I'm going to come up to the curve, and then I'm going to come over here to the percentage. And I'm going to need to do some more labeling here. Here's 65, 70, 75, 80. So it looks like about 80%. In the year 16, that's 2021, which is this year, it's 80%. So the answer in 2021, we predict 80%. This is the answer to C. And now, question D, estimate when half of Americans aged 12 or older had listened to online radio in the last month. Half means 50%. That's our first percent tweet. So we find 50% now on the percent axis. We come over to the curve, which is right here, and come down. And it looks like it's between 2000, T equals 9 and T equals 10. I think I'll use T equals 9. So for part D, T equals 9. Now, what does T equals 9 mean? Remember, that's 9 years after 2005. So we're going to get 2014. In 2014, about 50% of Americans listen to online radio. My answer is 2014. Okay, the second example I'd like to do today is number 9. Let's read question 9. The percentages of Americans who use wearable devices such as fitness trackers and smartwatches are shown in the table. Obviously, this has been has been quite popular. This one is not with years, but with age groups. So 25 to 39-year-olds, 23%, 35 to 44-year-olds, 22%, over 65, only 6%. So it looks like the older people get, the less they use fitness trackers and smartwatches. Now, our two variables are given to us in the problem. Sometimes that's the case, and sometimes we have to define them ourselves. So let's take a look at what we have here for our variables. A is the age in years. And so that's our input. So let's write that down on our paper. This is question 9. The input is A equals age in years. The output is P, the percentage of Americans. P equals percentage of Americans. And we're constructing a scatter plot. These are the input values. So now we're going to have to set a scale for both the input and the output. So let's set the scale for A. My largest value is 70. Scale for A. 70 divided by 10 is 7. So I could use 5 or I could use 10. Those are both pretty convenient. Maybe I'll use 10. Now the scale for P. The highest percentage is 23. Scale for P. 23 divided by 10 is 2.3. I'm going to use 2. Each square vertically is going to be 2. So let's set up our axes. So here's 0, that's the baby. They're not even 1 year old. Each square is 10. So we have 10, 20, 30, 40, 50, 60, 70. That's on the horizontal axis. This is the A axis for age. It's the input. Input is always on the horizontal axis. Now our scale for P is 2. So each square is 2. 2, 4, 6, 8, 10. And the largest value here is 23. So I need to go up to probably at least 24. And this is the P-axis. Now we're ready to plot our points. The first data point is 29.5, 23. 29.5, that's basically 30, 30, 23. So I'm going to come up here. Here's 24, here's 22. 23 is going to be halfway between. So there's my first data point. The second data point is 39.5, 22. 39.5 is basically 40, 40, 22, which is right here. 49.5, 15. That's basically 50, 15. 50, there's 16, there's 14. Halfway between 14 and 16 will be 15. 59.5, which is basically 60, 60, 11. Here's 60, here's 12, here's 11. And finally, 70, 6. 70, 6. This is our last data point. This is part A, construct the scatter plot. Now get a linear model. And today on this first assignment, we are not getting the equation. We are just simply using the line itself and the graph. Question C, estimate when, estimate at what age 13% of Americans use wearable devices. 13%. That's a percent, which is on this axis. So I come here to 13 and come over to the graph and come down. It looks like about 59 years old. So part C, 59 years old. Question D. Find the p-intercept. The p-intercept is where it crosses the p-axis. This is the p-axis. And I need some more labels here. Let me get some more labels on here. It looks like about 35. And we need an ordered pair for this. It will be 0, 35. And what does this mean in this situation? The first variable is the age. So this is a brand new baby, age 0. And the second variable is P, which is the percentage of Americans. That doesn't make a whole lot of sense here, but we'll go ahead and answer the question. 35% of new babies use wearable devices. That doesn't make a lot of sense, but it does answer the question. This would be extrapolating, going beyond the data, and extrapolation is a little bit dangerous. Question E. Question E. Find the A-intercept. The A-intercept is where it's going to be crossing down here on the A-axis. So this looks like about maybe 86. 86, 0. What does this mean? Age and percent. At age 86, 0% of the people use wearable devices. At age 86, 0% of the people use wearable devices. It's very important to understand what these numbers mean. Let me emphasize that again. It's very important to understand what these numbers mean. As usual, once we explain the material on the handout, the assignment is made. So please get started on this assignment, and we will be answering questions on this in class. Since you're making these graphs, I'm not having you do very many of these. This has been a video on section 2.1, using lines to model data. Have a great day.